Welcome to this explainer. Today, we're taking a chronological journey through building an optimal Power BI report. Think of this whole process exactly like building a house. You wouldn't start picking out the living room curtains before the foundation is even poured, right? Well, your data is exactly the same way. We've got to lay the groundwork, put up the structural framing, run the wiring, and then, finally, execute that interior design.
Okay, let's dive right into this structured data journey. We're going to hit Power Query best practices, structuring your data model, calculated columns versus measures, decoding that DAX filter context, and wrap it all up with designing high-impact dashboards.
Step 1. Power Query, laying a solid data foundation. We begin our journey right here, which serves as the foundational concrete of our data house. If this is cracked or inefficient, trust me, everything built on top of it is going to suffer.
When you're wrangling your data in Power Query, performance is absolutely everything. You have to remember one golden rule: do expensive operations last. Streaming operations like filtering are super quick. They only read just enough data for a preview, but expensive operations like sorting force the system to read the entire data set before returning a single result. If you do that too early, your editor is going to slow to an absolute crawl.
So, what's the ideal chronological order to keep things zipping along? First, start with the most efficient connector you can, like native SQL Server instead of ODBC. Second, filter out irrelevant data immediately. Just get rid of it. Third, do your streaming operations. And only at the very end do you want to tackle those heavy, expensive sorts. Now, to really future-proof this foundation, you gotta build smart. Is adding steps starting to feel a bit sluggish? Just temporarily keep the first few rows while you're working. And more importantly, don't build one giant monolithic query. It's much better to chunk your logic into modular pieces. You can use parameters to maintain flexibility, and hey, if you're repeating the exact same transformations over and over, just turn them into reusable custom functions.
That brings us to part 2, structuring your data model, the architectural framing. With the concrete poured, we have to put up the framing that holds this whole thing together.
When it comes to that framing, the star schema is absolutely king for DAX performance. You've got a central fact table holding your measurable data, like sales, surrounded directly by dimension tables that describe those entities, like your products or time. The snowflake schema might look really elegant with all its sprawling branches, but honestly, those complex relationships are just going to drag down your performance. Keep it simple, keep it star.
Moving right along to part 3, calculated columns versus measures. This is the plumbing and electrical wiring. Next up, we install the utilities by deciding how to calculate your data effectively.
Let's actually start by pinning down exactly what a measure is, because its dynamic, context-aware nature is super critical here. A measure isn't just some static piece of data sitting in a table. It's a formula that literally springs into action at query time. It looks at the filters you have on your report and calculates a result completely on the fly. So when do you use those RAM-heavy columns versus the CPU-heavy measures? Well, calculated columns evaluate row by row, and they are physically stored in your model, which eats up RAM and inflates your file size. You really only want to use them when you need a static value for a slicer or an axis. Measures, on the other hand, don't store values. They use your CPU to aggregate data dynamically. For things like a weighted average or a profit margin, a measure is definitely your go-to.
All right, part 4, decoding DAX filter context, understanding dynamic conditions. With our wiring all set up, we really need to understand how the electricity flows by decoding the invisible force that makes those measures actually work.
Think about this for a second. Why does the exact same DAX formula produce totally different results? It's kind of a puzzle, right? Every single cell in your report evaluates expressions in a completely unique filter context. When you write sum of sales, it doesn't just spit out the grand total everywhere. That number morphs depending on exactly where it sits in your dashboard.
Imagine a single cell in a matrix. It's actually the exact target intersection of multiple dimension filters acting as a table. A number like 8,700 isn't just a random sum. It's the precise result of the data model filtering down to only the Contoso brand, only the color blue, only the year 2019, and only the US and Canada. All those converging conditions, that is your filter context.
But what if you want to bend the rules a bit? Say you want the percentage of total sales for just one single color. You have to surgically manipulate that invisible context using specific functions. Calculate is your master tool for this. Inside Calculate, you can use remove filters to strip away a condition, like ignoring color entirely to just get a grand total. Or you can use keep filters to ensure an existing condition isn't wiped out when you introduce a brand new one.
And finally, we reach part 5, designing high-impact dashboards. The interior design phase. It is time to craft that user interface. Look, your foundation could be solid, your wiring could be perfect, but if the house itself is a mess, nobody is going to want to live in it.
Good design is strictly about making your data clear and actionable. It's not about making it decorative. Before placing a single chart, you've got to ask yourself, what decision does this dashboard actually help someone make? A strategic executive dashboard needs high-level KPIs and minimal clutter. But an analytical dashboard, that requires drill-down capabilities for managers. They demand completely different user experiences.
To achieve that clarity, you absolutely need a strong visual hierarchy. In Western languages, viewers scan in a Z pattern, so put your most important high-level KPIs, things like total revenue, in large cards right up at the very top left. Size signals importance. If everything is the exact same size, nothing stands out. Keep your slicers up top, where users naturally expect them, and group related charts together with clean, consistent spacing.
When you're picking your visuals, simple, clean comparisons will always beat out distorted 3D charts or messy pies. Pie charts fail dramatically if you have more than 3 slices because the human brain actually really struggles to compare angles. And 3D charts, they literally distort data perception, making certain values look artificially larger. Stick to clean, 2D horizontal bar charts for comparing things, line charts for showing trends, and reserve your bold colors like red and green strictly for performance indicators, not just decoration.
I want to wrap up this explainer by throwing down a bit of a challenge. Apply these optimizations to your own data house today. Think about the reports your team uses every single day. Are the queries efficiently loading? Are you leveraging the incredible speed of a star schema? Are you strategically manipulating those DAX filter contexts to get the exact insights you need? And most importantly, when a stakeholder opens your dashboard, do they know exactly what action to take in 10 seconds? Or are they just met with a wall of confusion? The tools to build a masterclass data product are right in front of you. So, what are you going to build first?